and cybersecurity and educate and connect you with the fellow professionals. The third area of FDPS cybersecurity reflects our commitment to develop learning research skills in the faculty. We believe that this event will provide a valuable platform for knowledge sharing, collaboration, and growth. Once again, I welcome you all for this wonderful faculty development program. Rajesh sir, please check. Ma'am is joined.
Okay, ma'am, I'll check. Ma'am.
Ma'am is trying to join. Sir, please check.
Okay, ma'am.
சும்மா இருக்கணும்.
Participant, please, thank you for your patience. The link is not connected. Ma'am is messaging me. Some network issue, I think. Rajesh sir, I have sent the mail ID of ma'am mail ID. So you have checked with the mail ID. Not able
Okay,
to
ma'am.
log
I will
in.
check it, ma'am.
Sir, any meeting code is there?
Right, ma'am. I will share it.
Ma'am is asking meeting code. Due to network issue, it is respond like that. It's saying maybe a network issue. Sorry for the delay.
You hear me?
Ma'am is joined now.
Anna,
Yes,
are you there
ma'am.
in the
Wait.
line?
Yeah.
I am having some network issue
Good
actually.
evening to one and all present in the pleasant evening. Okay, ma'am. Okay, it's okay, ma'am. I request all the participants to join now. It's my great privilege to welcome you all for the ACT sponsored 6 days FDP on enhancing cyber threat detection through incorporating digital technologies for the day 3, session 2. Now I call Ms. Khirija, Assistant Professor, CSE, to give the introduction about resource person.
Yes, ma'am. Am I audible, ma'am?
Yes, yes, yes.
Yes,
Yes, yes. Good evening to everyone. I'm Girija, Assistant Professor in the Department of Computer Science and Engineering. It's my privilege to welcome you all for the Day 3, Session 2 Faculty Development Program on enhancing cyber threat detection through incorporating digital technologies. Today, we are honored to have an exceptional speaker with us, Dr. Shibarani ma'am. Dr. Shibarani ma'am is a distinguished academic and researcher with extensive expertise in the field of electrical engineering. She holds a PhD in electrical engineering from Anna University, Chennai, and brings a robust educational foundation with degrees in engineering from esteemed institution in Tamil Nadu. Currently serving as a professor at the Indian Institute of Space Science and Technology, Trivandrum, Kerala. Ma'am has over 2 decades of expertise in teaching and research. She specializes in computer vision, image analysis, and digital VLSI design. Her research work focuses on design and performance evaluation of hardware solution for advanced signal and image processing technique. She has a rich portfolio of publications and contribution to her career, reflecting from commitment to advancing knowledge in her field. She is also an active member of professional community, holding a senior membership in IEEE and affiliation with IEEE Women in Engineering, IEEE Circuit and System Society, and IEEE Remote Sensing Society. In her academic role, she imparts her knowledge through a wide range of undergraduate and postgraduate courses, including digital electronic signal and system, real-time DSP, and advanced VLSI design, among others. Her dedication to fostering learning and innovation makes her a valuable resource in the field of electrical and electronic engineering. We are honored to have such an innovative and visionary leader to share her expertise with us today. Without any further ado, I now hand over the session to our esteemed speaker, Dr. Shibarani ma'am. Let's give her our virtual applause and full attention as she begins her presentation. Over to you, ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you. Okay. So today we are going to, as per the topic, okay, it is predictive analytics for cyber security. Could you hear me? Audible?
yes, ma'am.
Yes, no? Yes, okay, no problem. Yeah, sure. Uh-huh. So on the outset, even the title we are having, it's predictive analytics for risk assessment for cybersecurity, right? Initially, we'll be seeing about the definitions and the types. Later, we'll be going for one of the mathematical method, that is logistic regression. What is logistic regression? What is maximum likelihood? And how this prediction take place and what are the benefits like that. So it's not a very long lecture. So today it's a lecture that already you know, but we can able to recollect what we have learned earlier in our career in this predictive analytics. Okay, so I'll share my screen for the initial um, concepts. Then screen. Whether my screen is visible?
Yes, ma'am.
Fine. Okay. So that's, I have told it, the heading is predictive analytics for cybersecurity. Okay. So what is predictive analytics? As we know, predictive analytics is a data analysis process that uses statistical models, machine learning, and artificial intelligence to forecast future outcomes or to predict future outcomes. So why that is required? Why prediction is required? We are having the present and the past information. And now, based on the present and the past information, we are just going for a prediction. The main thing is that wherever the applications of any applications, there is a risk, or we have the concept of risk assessment. And if that happens, it will create a worst scenario. So, for example, in the here we are just seeing in terms of cyber attacks, right? But in a physical world, in the earth, we are saying cyclone. When you're saying it is cyclone, once it is started, right, within hours, or we can say it's minutes, sometimes, most of the times days, 2 to 3 days, 2 days like that, it will just evolve and it will create a lot of impact. That means damage to the human being. So one of the important thing required is that before weeks or before months or before hours or like that, if we are having a prediction for such type of risk applications. Okay, so one of the application I'm saying it is risk, and also we can say in health sectors. Okay, health, medical side. We are all human beings, and we any risk factors which we are having to get some diseases or something that is very much important. So based on the past history or the present data or like that, if we have prediction analysis is there, that means predictive analytics is there, that will also reduce the risk. So predictive analytics from risk assessment plays an important role in critical applications. So like that, cybersecurity is also one of the critical applications because the impact when the securities get tampered or the intruder can able to get the data. So the impact, it is based on the different environments or the infrastructures we are having. It can be organization level infrastructures, or sometimes the whole world will be get affected. So another one application we can say this predictive analytics will help in stock market. You know, the stock market is a time series data, and every day people depends on the prediction, right? If the prediction is good, okay, good business people and planning, stock market investors can able to plan it properly. But if the prediction is not good or it is not giving a proper output, then uh, based on that, the investors can't able to take a good decision. So suppose if I'm saying that the index for the particular, the base unit value, right? For a particular share, it's saying that for 1 unit it's 500. Instead of that actual value, it turns to be 100. You see the scenario of the people who are investing in that particular share, which wrongly predicts that, okay, its share will be tomorrow, it will be 500 or 300 or like that, right? So these types of risk factors related applications, this prediction plays an important role. And also we can say prediction also helps in reducing the data which can be stored. We know that that is not a predictive analytics, it is prediction. So here it is, after prediction, we'll be having some analysis or like that to reduce the risk. So now you see predictive analytics can help organization reduce risk, improve processes and make better decisions. So reducing risk, first thing, so we have seen that banks use predictive analytics to assess the risk of mortgage applicant and determine how much money and interest rate to offer. So they will be having a predictive analytics. Based on that only they will be setting or fixing how much the rate interest can be or like that. It's one of the example. This content I have taken it from the general web, okay, for you making to understand. Then improving processes. Human resources can use predictive analytics to identify future workforce skill requirements and reduce employee turnover. This is one of the example, improving processes, right? So prediction will help us that how our business has to be. Here in this context, it has told how many number of future persons required for doing these types of things or like that to plan. So on the outset, we can say the superset is to plan it properly and to make a safe environment, right? Then making better decision. Prediction also helps in making better decisions, especially in cybersecurity. When we are seeing decision plays an important role because when there is a prediction analytics saying that the risk is high, then it has to be a closed loop, right? And it has to take suitable responses. Defense response. We are saying that defense response mechanism need to be in place in any organization if we have incorporated the predictive analytics in their cyber threat reduction techniques or cyber security monitoring systems, right? So these are the predictive analytics help. These are the things. So surely we say that it is an important topic that in cyber threat attacks, predictive analytics plays an important role. So in this context of cybersecurity or in general, predictive analytics is a data-driven approach, right? That uses, so main thing is that historical data to anticipate and mitigate cyber threats. So the first requirement for any predictive analytics is that requirement of data. So how good the data is, that based on that, how the variance of the data is, different groups of data or group of sets of data. So based on that, we can say, okay, the prediction will be nice. But if the data sets miss some of the good data, so then we can't able to get prediction proper. But there do have some techniques like interpolations based on the predicted data or like that. Based on that, we can also generate some good data and we can predict also. That is also possible. Next, it involves so data. So first thing is that predictive analytics required the first and foremost thing. It involves collecting, analyzing, and applying data from various sources. Right? You see, for example, it is given in this network cyber threat is based on computer resources, internet network traffic, user behavior, then security logs, threat intelligence feeds. So we can give some threat intelligence that if it is one, so you have to do like this or something like that, along with the normal deduction, conventional methods of checking the signature patterns or like that. Along with that, we can augment threat intelligence, right? So main thing is the data collection. Second thing is that analyzing, right? The data and applying, analyzing and cleaning the data, what type of data we can give for prediction, removing, that means in predictions, we can say how the outliers can be classified, how it can be handled, odd man out data. Those things are required before prediction. Then risk assessment. Next, I'm introducing a term that is risk assessment in cybersecurity is a major shift from simple remedial methods to proactive methods of operations that we'll see, right? So now earlier we don't have these step. Prediction will be there, followed by a risk assessment based on the predicted value. So it improves the quality of life. That's all, right? So it becomes proactive. Earlier we'll be taking simple remedial methods. Right now, now parallelly, before hours or before things, we are going for prediction something. But if the prediction goes wrong, what will happen? That is an important thing, right? Okay. So here, what are the different types that will come later? Okay. So now you see predictive analysis in analytics in cybersecurity. This approach not only enhances the prominence and efficiency. This approach means it's not a specific approach. I mean, these types of prediction analysis enhances the prominence and efficiency of cyber protection, but also rationalize resources and actions. Essential components of predictive analytics include data quality and cyber threat intelligence, which ensures that the data used in the models are up to date and relevant. So every time when you're just using the data, we have to see that the very latest data are captured, whether the data set is updated or upgraded. That is important for a prediction, right? So these things and all I have taken it from this paper. Enhancing cybersecurity through predictive analysis, real-time threat detection and response by Mohammed Danish. So then everything I've taken from there only because I couldn't able to see the actual textbooks or relevant things, but some papers only I've referred. Okay. Next is that, so when we incorporate the predictions, what is the name of the system? Okay. Before prediction, the cyber threat reduction techniques or cyber threat reduction analysis, right, systems are called reactive systems. The old primitive systems, right, are reactive systems. So what is reactive systems? Systems mainly target threats as they emerge, and hence once the threats emerge, and at once they involve in treating that threats, how to overcome that threats like this. That means in a network environment, network security, or in a cyber physical system, we'll be having a system which constantly monitoring the cyber attacks based on the patterns they have stored in their network or computer, whatever. So if there is something wrong, and if they have found out that, okay, something is going wrong, then based on that, immediately they respond. So now you see the other reactive approach. What is that second line? It is saying, see the reactive approach will sit back and wait for that, and this was a disadvantage. So reactive system means if anything comes, only it will act. That's why it is waiting and observing anything happens or not, right? This method bases its operations on previous knowledge and in a way is ill-equipped to deal with threats since it directly targets the known types of attacks. So another one important characteristics of reactive systems are it won't expect for any new threats or like that because it is not having a sufficient data pattern or signatures in its hand, right? And it will be just seeing about the targets with known types of targets. If a new attacks has come or any new targets come, the probability of identification for the attacks is very poor in reactive systems. Okay. So it is actually not a good method. So it is not a very effective methods, right? Reactive systems. So predictive systems, you see, whatever we are talking is predictive systems. So predictive systems use techniques in analytical processing such as machine language, and statistics to avoid predictions of a certain pernicious occurrence of an event. Besides, as this approach focuses on analyzing patterns and trends from large amount of data for planning future actions. Okay, already we have seen it helps in the organization for risk level reductions, right? So it helps in making how much probability it leads to the risk when these types of systems identified some malicious attacks or like that. Okay, so this is actually predictive systems are very good, but for good predictions, one of the important thing is cyber a large data, because that is the characteristics or requirement of any data driven analytics, right? Any data driven systems, the more the data which is good, more the span of the data, the spread of the data which is good, then it can able to identify or define a proper prediction. If more number of mix of data are there, right? Then it will be easy for us to group or to predict that it will be coming more in the sense that meaningful data, which will outliers, if more outliers are there, which can't be predicted easily, right? Then it will be a problem that we have to use suitable techniques to predict properly. This slide says that you see cyber security threat reduction challenges. So we are having a cyber threat reduction techniques, which is present in any type of cyber environment, right? Network environment, or we can say cyber physical system environments, right? And we are deducting that is there any threats are there? What is the open challenges for that? Even though the models what we have made, it is good for a certain environments, right? But you see, the one of the important thing is that false positives, which is an alarm that a threat exists, although it is does not. So actual, it is not a threat, but our system will decide that it is a threat. So one of the challenge in any the cyber security model is the reduction technique is that first thing is that our ultimate aim to reduce false positive, because the cyber threat reduction techniques is followed by some actions, defense actions, right? So if we have good node or a good thing is decided as or defined as a wrong one, if we actually it is not a threat, but if we are defining as a threat, then the impact you see. So false positive sensitivity we have to improve when we are defining the cyber threat reduction techniques. Either it can be statistical, or it can be learning, or it can be neural network that we can see. Second thing is the scalability issues. Now, see, in an organization, we'll be having certain security methods that we'll be following. When once the organization or the institution or whoever is using that, if it scales up, then the same concentration of defining and protecting each and every node of the computers is required. But if that is not taken care, if the network is get expanded and if not proper procedures are not taken care to strengthen the security of each nodes, then it will be the problem that when it is going for any breach of security, so like that, right, it will affect. So the cyber threat technique, which the reduction technique that which we are implementing in any networks, right? If it is scaling, that same type of reduction rate need to be there, right? So then, what is meant by that? Each and every node points has to be monitored at the same way that when the number of nodes is minimum, because monitoring is not a easy task. Every time when you want to monitor a particular node in your network or a particular communication in your network, who are all communicating, right? How many people are there inside, outside? One will go, if it is a mobile node or networks, one will go after some time, another will come, so many things. So power wastage is also will be there. lot of things we have to take care when we are expanding our infrastructure. That means not cyber physical systems or the network structures. So the monitoring capability also has to be scaled up properly. If it is not scaled up properly, then there will be a flaw in the cyber security systems. Okay. So false positive, scalability issue, zero day vulnerability. It's an important vulnerability. This is mainly we are talking about software. Suppose a software is developing some software and he don't know that there is some flaws in the software which can be taken as an advantage by the intruder. Because when any new software comes, the what to say that the cyber uh, theft boss, right? Who is the boss? He will be keenly watching and he's trying to see that whether any of the attacks can be done in the software, so the full entire software can be crashed, or while people they are using the software for some applications, whether they can able to eavesdrop the data which is used by that particular application. So like that, the intruder will be keep on watching that, and he'll be maybe intentionally he'll be purchasing the software and he'll be studying the software and seeing that is there any flaws or like that. That flaws can be used for damaging or creating some cyber threat attacks, which is a huge loss. So, but if such attacks are made without any delay, the vulnerability or the that has to be overcome. But whether it is possible or not, because if you see that the most daunting challenge is the reduction and management of zero-day vulnerabilities, which are flaws in software that the software maker does not know about and for which no patch exists at the time of discovery. When it is discovered that something happened, there is no alternate or solution because the developer itself has not known that this type of error or this will come. It's a very high level. That means we can say that normally they'll be doing for all sort of bugs, possibilities and case studies they will be making. But in some cases, for a very rare, rare things, right? It won't satisfy or it will be giving some. It may create a security breach. So the challenge is zero-day vulnerability. Is that so? How cyber security systems will overcome that? To overcome this vulnerability is also challenge. So most of today's detectors lack escalation mechanism and may fail to monitor all points, right, of vulnerability to breaches when the network is growing. This is scalability. Zero-day vulnerability also same thing, right? So here we can say single party software or a third party software. The risk level is more for a third party software. Last class we have seen about the Trojans, right, which is introduced in the third party level. So when it is put here or like that, we don't know that how that confidence of trust in these types of softwares or networks that plays an important role. That also predictions need to be done. All right. So this is so important requirement for predictive analysis. Viable predictive systems also requires first rate and pertinent data. So you see already I've told you very good quality data to educate the models because all the predictive analysis systems depends on the data in which you are using to predict that are used in the prediction and provision of attack prevention. Okay. So what are the different? This is general that we will be seeing three types of predictive analytics are there. Okay. So what are the three different types of predictive analysis in general? In cyber attacks also, we are using this type of predictive analytics methods only. The first method is regression analysis. Okay. So in regression analysis, what is regression analysis? Today we are going to talk about one simple regression analysis. logistic regression. Okay, it's a common method, but once again we can see that actually what it is happening. Regression analysis is a fundamental technique in predictive analytics used to model the relationship between a dependent variable and one or more independent variable. Okay, and it is used the score of probability to predict or to classify, right? So the goal of regression analysis is to predict the value of the dependent variable based on the value of the independent variables. Okay, based on the values of the independent variables, it will be predicted. Second method is the time series analysis method. So the time series analysis method focuses on analyzing and forecasting sequential data points collected over time. So one example of time series data is stock market data. Okay. Then weather forecasting data. All weather forecasting or climate-based informations are time series data. Why? Because the data will be changing based on the time. Stock market data, we can say it is time series data, right? It involves studying the patterns, trends, and seasonally in the data to make predictions about future values. So that is also a required. So if there is a time series data, then we have to go for time series analysis, right? We have to go for time series analysis. Machine learning algorithms. Third method, now you know today's era, everywhere predictions, we are going for machine learning algorithms are good because I can generalize that, but if the data, because these predictive analysis anyway require data, right? And so when we are having good data, better sets of data, then machine learning algorithms are good. Now we can say neural networks. So now you see machine learning, encompasses many types of algorithms, including here we can say decision trees, random forest, support vector machines, k nearest neighbors. Then we are saying neural networks, logistic regressions. These are all the different techniques that we are using for the. It is inherently taking these steps of techniques in the machine learning approach, right? And so we are having three methods that we'll be having for that analysis. So now this is one thing that one block diagram, right? I've taken from paper that that machine learning model for threat detection. Here it is not incorporated the prediction analysis. Only what this model is doing is the ML data model, ML algorithm, training data we require, real-time data, right? Reprocessing, feature extraction. Then we are saying it is processor. Decision making is done here. Alert and decision engine. So this is nothing but a reactive system, right? Here I have not done any prediction, right? We have already trained the data. Then we are taking some data and we are putting it in some classifiers or like that. We are based that we are saying that whether alert and decision engines will be taken. So it is nothing but we can say reactive systems. So if it is a predictive systems, then we are saying it is proactive. Okay, what is the next event? What will be happening or what are the things based on the input data? It will be predicting the events, predicting the risk also. So that has to be suitably incorporated. So machine learning algorithms can be used for making predictions, right? That is my claim. So, okay. So now we can see, I will be taking that is okay. Regression analysis, that means especially logistic regression. Okay. So now you see that what is the what do you mean by logistic regression? What is linear regression and how it is used for prediction? So I told that it is, I'll be using some of my okay, one slide which is blank that I've taken. Okay, so here I can take it. You just tell me that whether it is visible. The new screens. Waiting. Whether my screen is visible, right? Right now. So we are talking about now regressions, linear regressions. Okay, linear regression. This is for used for prediction. So linear regression means, suppose it can be when we are seeing that these regression models are used for predictions, right? Classifications, we'll be saying that it is used for classifications. So here also we can say that the cyber threat techniques, right? So we cyber threat reduction techniques, based on the cyber threat reduction techniques, we'll be having the data, right? And what we will do is that normally when we are having a classifier like thing, right? What we can say is that in classifiers, we'll be having, if it is a binary classifier, okay, binary classifier, how the data will be, because here mostly we are talking about data. So if it is a binary classifier, you see two classes, okay? So based on what we'll be defining the classes, that is important, right? So we can say it is a two-class problem or a two-class reduction means whether the attacks, if it's a cyber threat is present or not. So what type of data it is present, cyber threat present or cyber threat not present. Based on the data, it has to say that present or not, right? So for saying that the cyber threat data is present or not present, we require some attributes, right? So the important thing is that we have to define some attributes. The attributes, it can be attributes or attribute. So first we can see about one of the characteristics in which it is present or not present, right? So if there is a cyber threat attacks, when we are saying, so really we'll be just saying that some imposter will be there here in this. If the imposter is there, if I'm saying that some imposter is there, then we say that, right? Sorry, if the imposter is here, then we are saying that some threat is present. If there is no imposter, then we are saying not present. That means last lecture when I'm taking, we have taken about anomaly deduction, right? We'll be seeing some patterns or signatures, and we are doing this. So now you see, so this is the x-axis and y-axis. Okay, so we have now two categories, present, not present. So based on the patterns, or we are saying that one attribute we want to define, right? So this patterns is highly correlated or not, like that we can say, right? Known patterns or unknown patterns. All known patterns, if I'm saying that it is it is not a cyber attack, it is a data, no attack is there, right? So some data which is having two-class problem, right? Which is here, right? It is not, yeah, cyber attack is not happened or like this. Another one is that I'm saying that these are data, two data. Now you see that is a clear demarcation between these two data, right? So we can say that when it is here, it will be having the data which we are having, that there is no fear of cyber threat. But when here, when it is going like this, right? When the patterns, whatever we are using is different. This is same. There is no change in patterns. Here there is a change in pattern. So we'll be having a different class. Sometimes when you're making data, I have told no, this is a good data. because it is fully like this 2-class problem. Sometimes my outliers, I have used the word outliers, no? Sometimes the data can be like this also, some outliers. So see, here also, here also. These outliers are there. So outliers are odd man out, which is very difficult to separate it out. So we require sometimes to remove the outliers, we require some logics, or we have data cleaning methods or like that. So before predictions, conditioning of the data, the quality of the data, and the large sample of data is also very much important. So now see linear regression, what we will do. This is a pattern, same pattern or a different pattern. So we are getting here. So we can say that this is one category. What is this category? Two categories only. This category is that the cyber attack has happened. And this category is that cyber attack has not happened at all. When the patterns are not changing, then cyber attacks has not happened. When the patterns are changing, then cyber. So patterns are changing means here it is. I'm just making. So this is the attribute we are making, right? So when you're making this attribute in linear regression, what we will do now? We'll be fitting a straight line here. So we'll be fitting a straight line here. So when you are fitting a straight line, right, in linear regressions, for classifications, instead of making a very straightforward thing like this, that means cyber attack not present, cyber attack present, like that. Instead of that, we'll be defining this y-axis when it is a regression model. We'll be defining this y-axis using the probability. Okay, so probability of cyber attacks, right? Probability of cyber attacks. Now you see, here it is same pattern. It is not changing. Like here less means same pattern. But when it is going right, it is moving towards the category 1, right? This is category 1, this is category 0, two-class problem. It's moving to. So how will you define that? We will be saying if this is the data which is coming, we want to predict what is this, right? Whether it is an attack or not. Vertical line, then we'll be saying here like this. Then the probability of the cyber attack, if it is greater than 0.5, then we'll be saying that, okay, the cyber attack is present. This is normally a straightforward. And if it is less than 0.5, we are fixing that and it will be saying that false here. The data is like this, right? Now you see it is a linear regression model. We are just making with a straight line, right? So when you are making with a straight line, when the pattern changes very drastically, our data will also be, the pattern changes very drastically means it will be coming here, right? Right. When we are just classifying this, when the patterns are changing like that, when it is coming in this direction, in this way, when we want to find the probability, okay? So this is classifier, probability always ranges from 0 to 1. But when for the data x-axis, there is no limit, right? This attribute is not having a limit. The value of the attribute is not having a limit, right? So pattern means any type of patterns with their particular magnitude if you define. So if it is keep on increasing, if you want to find the probability, you see that it will be going like this, right? So at that time, the probability is going to be greater than 1, but practically it is not possible, right? One thing. And this equation is a straight equation that we know. It is y is equal to some mx plus c, okay? But one problem is this, we are defining probability, but when the input data are not confined to a particular range, when it is going towards this, because the x-axis is thing, then the probability which are giving is greater than 1, which is not at all possible. And these methods that we do for logic regressions, that means a regression that is to predict the values by giving this probability, wrong probabilities, we can't able to do thing, right? So what we are doing is that, so one thing, next is that you see y is equal to mx plus c. X is an dependent variable, right? It's, yeah, c, m Like that is the constants that we have to find, right? So x is a independent variable, sorry, x is an independent variable and y is a dependent variable. And to find y of dependent variable, it has to depend on the independent variable and also the constants m and c. So this linear regression can't play an important role because it is facing this difficulty. Okay. So next we are going for the next method, that is logistic regression. Okay. So in logistic regression, I'll take one next slide. Okay. With that, we will close it. Okay. Too much of things are not also logics. With that concept, we can see how we can go ahead. In logistic regression, same problem with different pattern levels. It is not discrete now. We are saying pattern levels are also continuous. Okay. Here also probability of cyber attacks, right? Probability of cyber attacks. Right. So next is that. So anybody is calling me? Whatever I'm speaking is audible, right? My screen is visible. Okay. So now we are having the same patterns, right? I think all are sleeping. Same patterns with some outliers. I'm having patterns like this. And we have two binary class problem, which is that there is no cyber threat probability 0. There is cyber threat when there is probability is 1. Now we want a function which is not like this function like this, right? Because it is just giving some erroneous outputs. It's not giving the probability proper. So what we are doing is that we are going for sigmoid function. In logistic regression, we'll be going for sigmoid function. Okay. So when we are going for sigmoid function, you see the function, we know what is that function, right? How it will be like this, right? So when you are going for sigmoid function, right? How the sigmoid function will be having sigma of x. Okay, it is sigma of y. From that I can draw here. Okay. Normal sigmoid functions will be having both positive and negative. So here if I'm drawing, this is the 0. 0 means just to show you, this is 0. Normally sigmoid functions will be, right? You know that it is like this. Now what is the difference that we are seeing here? So what is the difference we are seeing here as compared to that of the earlier logistic, what to say, linear regression, right? How we can able to see one saturation level we are making, right? Even the data are going very high, right? Even the data are going very high. If it is extended, we don't want to limit it. It will be showing the probability of defining, right? Probability of defining that in a category is category 1. Okay. Category 1. Okay. So now you see this is easy that even if it is going like, but now the sigmoid function is having both positive and negative values. This is positive and negative values. But practically when we are just seeing some problems, we won't have these pattern levels, levels of patterns, how we are defining the scores. It is based up to us. It cannot be negative. So what we will do is that we'll be shifting our regression. We'll be shifting our sigmoid function here, right? So when you are shifting this point, this has to be shifted here. So it will be shifting. So our sigmoid functions will be like this based on your problem, because all are positive means it will be like. So now the linear equation problem can be solved by defining the sigmoid function and providing saturation. So the probability. So here you see logistic regression, or regression means probability, right? So whenever we are saying that this probability, so what is the now sigmoid function called? The sigmoid function is equal to, sigmoid function is equal to a sigmoid function. Okay, sigma of x, okay, is equal to 1 by 1 plus e power minus sum. Hence, we have to define some variable c plus d into x. Okay. So this equation that is earlier we have mx plus c, same thing we can put here. Instead of c plus dx, it is mx plus c, right? So this is sigmoid function. So when we are just defining the sigmoid function, right? How will you define the probability of this function? That is important. So now you see that c values and d values we have to find. For various values of c and d, and for the particular, right, independent variable, we'll be getting a dependent function, right? And we'll be just plotting it. So here we have to find the probability. From this, we have to find the probability. We define the sigmoid functions. Now, what is the probability? Right? Probability of being in category 1. When the data x, here this is the data, any data is equal to some xi or something, right? Probability of category 1 when x is equal to x1. This is given as probability of the data xi, right? It belongs to category 1. So what we are saying is that it can be simply by 1 by 1 plus e power minus c plus d into xi. Right? This is the equation. So this is the probability. We are saying probability of category 1 when x is equal to xi is equal to this equation. Next, automatically we know the probability of category 2. Category 2, category 0, this 0, this 0, 2 categories is equal to, this is probability, right, of xi is the probability of category 1. Then we are sure based on the probability concept, we know it is probability of, right, 1 minus p of xi. So now 2 probabilities we have got. Okay. In logistic regression, what we will do is that, okay, we will be taking, okay, one equation that when we are seeing that equation, it will be like odd man out. But when it is really, when I'm explaining, you can able to understand. So what is the probability actually for this logic regression? How will you find this probability? P of y is equal to yi, provided x is equal to xi. Whatever may be the category, if this is category 1 or category 2, we can write this equation as P of xi. Now here we are incorporating the output dependent variable yi, okay? Yi into 1 minus p of xi into 1 minus yi. What do you mean by that? If it is category 0, what happens? Category 0 means yi becomes 0. When yi becomes 0, p of xi power 0 is 1. 1 into 1 minus p of xi is the probability. So this equation satisfies, no? When yi is equal to 0, this equation satisfies. When yi is equal to 1, this equation satisfies. When yi is equal to 1, what happens? 1 minus 1, 0. Here it is 0. So 1 minus p of xi, 0 is 1. So the equation will be p of xi. So we had now, this is the probability equation. This function, right, we are making it to a likelihood function. So what is likelihood now? We are having various values of x1, y1. Based on the x1, y1, we are predicting the probability. So you see, for x1, y1, we'll get probability p1. For x2, y2, we are getting probability p2, provided that we have to assume some values for c and d. So initial assumption of c and d, we'll be getting some probabilities for endpoints. If you are having the data as endpoints, you'll be getting the probability up to n, right? Once you've got some endpoints, we have to, 1 minute. So what we will be doing is that only to teach you logistic regression for prediction, okay? So this we are just making product of P1, P2, P3 up to Pn, because the total probability is nothing but we'll be taking product, right? We know that this is the total probability for all the points. Total probability. So this is called, you might have heard about this, maximum log likelihood function. Okay. Maximum likelihood, not maximum likelihood function. What do you mean by that? We are taking the max P1, P2, P3, P1. So previous slide shows what X1, X1, Y1, P1. Among this, which is having the maximum, so many groups will be there, right? For A, B, we'll be having this group. Another one, A1, B1, will be having another one group. So for all values, whatever, how many times of values we are taking, we'll be having different groups. So we'll be just finding the max of L. So it is an optimization problem, right? Max of L, that defines that what is the best value of A and B, right? And the respective X, what is the category Y. So here, what is Y? Y is the probability. So we can able to predict probability means what? If unknown Xi is given, we have optimized the system by selecting the particular value of A and B, right? And we'll be giving. So now you see a likelihood function. One more thing I have to define. For 5, right? I is equal to 1 to n, right? P1, P2, P3, P1, Pn. What is this P1, P2, P3, Pn? Already we know the probability for the likelihood function is this, right? This is the equation, right? P of y is equal to yx is equal to this equation. Then we can say that now you see, this is replaced. All this can be replaced by this equation, right? P of xi ya 1 minus P of xi ya 1 minus P of y. Okay, this is the likelihood function. So now what we are doing is that which values of A and B that maximizes the value of L, right? Or we'll be finding the log of it. That's why I'm saying. So log of L, which point which is maximizing this log of L, right? That we have to find. So by just maximizing, now you see. So now we had now L is equal to within 10 to 9:30, no, till that I will finish. Okay. L is equal to you see, I is equal to 1 to n. This is the probability equation, P of xi, right? 1 minus P of xi, right? Into 1 minus ya. This is, we are saying it is ya, right? And we know that now, you see that we'll be having the L values, right? Normally, the ratios of 1 minute. Right? So now this is P of xi, 1 minus P of xi, 1 minus y. So all these products, so that we'll be saying, we'll be taking here the log L, right? This each and every points we'll be calling it as logits. Logits. Okay. That means each and everything, it is Pi. probability function, right? So when you're taking a probability function, maximizing and finding the log function, right? Then that would be giving the maximum value or L for a particular value of A and B. So this can be used in logistic regression because now you see L we are finding, and based on that we'll be getting the prediction values like a sigmoid function. This predictions, it will be somewhat good because it is not a very hard and linear thing, right? It would be dividing for a 2-class problem. Now you see, based on the probability, it will be bringing either our data to the right or left, right? So this type of classification model, or we can say prediction model, the probability prediction model is called, right, logistic regression. So fitting with, this is nothing but how we were getting this, fitting with the maximum likelihood function. This is called maximum likelihood function. So in maximum likelihood functions, we'll be finding P1, P2, P3 for n values, right? For different sets, we'll be just making, then we'll be going for a optimization problem, and we'll be just finding the which best value or highest value of probabilities, right? P1 will be giving the predictions that for which class it belongs to. Highest values of the probabilities will give that which class it belongs to, right? Higher the probabilities, then it will be a category 1. Lower the probabilities, then it will be category 0. Like that, it will be giving. So this problem we are calling it as, so, but it is a 2-class problem. So if my more number of attributes are there, now this is a very simple problem, right? More number of attributes are there, I will incorporate. Now you see sigma x is equal to 1 by 1 minus e power minus ax plus b, right? So if more number of attributes are there, the attributes are what? X. So here 1 minus e minus a x1, right? Plus some a into a1 x1 plus a2 into x2 plus a3 into x3. So the problem become complex. If I'm having more number of attributes and using that attributes, if you want to predict, then it will be like this. Then again, we have to go for defining the probability, then log likelihood functions. Then we have to find maximize this L to get the values, right? So this is multiple predictors, logistic regressions with multiple predictors. So what we have to predict now, right? So we are saying that we have to predict the probabilities with various values of this, right? So we have to assume A1, A2, A3 initially like that. So the problem become complex, but still we can able to get it, okay? So now you see, actually when you are taking the natural logarithm, right? The equations, what we are saying is that another one more equation I have to write. So from that we can able to get it. Okay, one thing, I'll just see that equation. 1 minute. So when we are just writing this as a logarithmic function, oh, today's session up to 9. Okay, with this I'll finish. I'll finish. Okay. So L is equal to, and we're just writing that equation in terms of logarithm only. We have to write this. So now you see, when I'm just writing this in terms of logarithmic value, this sigma of x is equal to 1 by 1 minus e power minus ax plus b, right? If I'm taking ax plus b and rewriting this equation, okay, it will be in the form of log of p of xi by 1 minus p of xi. Ratio of two probabilities, this is called odds. So odds, log odds, or this is called logits. Okay. So in this prediction analysis, logistic regression is the first method that we'll be doing for predicting where the probability is that if it is a single variable or attribute or a multivariable, two class, whether that something happened or not, right? Whether what is the probability, the rate that this happens or not, that it will be used. Apart from that, nowadays we are going for artificial intelligence clubbing with these things. Okay. So with this, I can conclude my session. Anyway, I'm late. Okay. So hope you have got at least some terms: logistic regression, time series, machine learning, what is maximum likelihood function, what we are going for optimization, odds, logics in predictions, right? Because we are all engineering backgrounds, we should know only these algorithms to work out. Otherwise, people in management and the other branches, they will be just writing some theories based on that. That's why I thought of focusing this. Okay, you can refer. Thank you. I thought it is from 9:30. Okay. Thank you.
Yeah, ma'am.
Ah.
Can you switch on your camera, ma'am? Photo session.
Camera, va?
Yes, ma'am.
Mm.
Everyone, please switch
But
on your
earlier
camera.
last lecture, we have not taken that, right?
Yeah, yes, ma'am. But the next is
Okay.
okay, ma'am. Any questions, you can put it in the chat box. Sir, please unmute all their cameras. Have you taken? Prabharan, sir.
Okay, ma'am.
Okay, thank
So,
you.
okay.
Okay.
Okay,
ma'am.
thank you.
Okay,
Thank
ma'am.
you. Shall I leave?
1 second, ma'am.
Complete.
I would like to thank all the participants and the eminent speaker, Dr. J. Shibarani, for spending valuable time with us. We can see in the upcoming sessions. Thank you. Thank you, one and all, for your listening. Thank you. Kindly fill the feedback form and then leave the session. Your support us more so that the session is going well. Thank you, one and all. Kindly fill the feedback form and then leave the session. Everybody is having NAC work, so IIT is also having NAC. So, ma'am, Kerala is also raining, so network issue is there. Some issues of online, so it will be delayed. Sorry for the disturbance to everyone. So I request all the participants to come tomorrow with proper time. I'll complete. Tomorrow we will end the session within the time.